In this video, we will talk about extraction of aluminum as one application of electrochemistry. As we all know, aluminum is the most abundant metal in the Earth's crust. Its main ore is called bauxite. It contains aluminum oxide or alumina, Al2O3. As any other cell for electrolysis, there should be an anode, a cathode, and an electrolyte. In this case, both the anode and the cathode are graphite, but with different shapes. The anode, the positive electrode, is graphite, big blocks of graphite that are hanging in the middle of the tank. The cathode, the negative electrode, is the coating graphite of the steel tank. So we have a steel tank coated with graphite from the inside. The electrolyte is the bauxite, which is the aluminum oxide. Okay, I will go back to that. Okay, the positive carbon anodes, you can see that they are blocks of graphite hanging at the middle of the container. The container is a steel container. Okay. The negative carbon cathode is a layer of carbon of graphite in the container, on the steel container. Here is the way for aluminum to be collected. Okay. The melting point of alumina, Al2O3, is too high. Therefore, instead of melting it and using molten oxide, the alumina is dissolved in molten sodium aluminum fluoride, cryolite, Na3Al(F)6. So, instead of having a melting point of 2045 degrees, we will have a melting point of 900 degrees. So this big difference will decrease the amount of energy used in melting the electrolyte. So the electrolyte that is used here, it's not alumina alone, it's alumina plus cryolite. So it's a mixture of alumina and cryolite. But the active material is alumina. And since the active material is alumina, it contains aluminum ions, Al+3, and oxygen ions, O-2. So now let's go to the process. How does the process take place? Aluminum ions will be reduced at the cathode to give pure aluminum. So Al+3 ions will be attracted to the cathode, to the negative electrode, and will accept 3 electrons and will give aluminum as pure aluminum. Al3 plus 3 electrons will give us aluminum. This aluminum will be collected as we saw before in the picture. It will be deposited at the bottom of the container and we can collect it. Oxygen ions will go to the to the positive electrode and will be oxidized there. So 2 oxygen minus 2 will give us oxygen, O2, and 4 electrons. So here the oxidation of oxygen will take place and oxygen gas will be produced. The overall reaction, the reaction at the cathode, Al3 plus 3 electrons, Al. Reaction at the anode, 2O negative 2, O2 plus 4 electrons. You can see that the number of electrons is not even, so we have to multiply this by 4 and we have to multiply this equation by 3, which will give us these two equations. By summing these two equations, the overall reaction will be 4Al3 plus 6O negative 2 will give us 4Al plus 3O2. The oxygen that is produced will react with the anode, which is carbon. So here it's just like burning of the carbon anode with oxygen, giving CO2. That's why the carbon blocks should be replaced repeatedly, because they are eaten with oxygen. You can see this link for another video.